Okay guys, this is Tutor Bracings yet with another video on but this time it's not mathematics, it's physics. So we're going to talk about acceleration time graphs to be particular. Yeah, this topic is one of the major topics which a person has to know in preparing for exams. So I urge your grade 12s, grade 11s, grade 10s to kindly go through the video, understand the concepts and apply it to different problems. So as you can see, we have I was trying to define some of the terms which you might encounter, like acceleration, which you know from your textbooks. Acceleration is just a rate of change of velocity with time. Velocity is a rate of change of displacement. So again, besides, you have again to know some of the most important physics equation when dealing with acceleration time graphs. So some of them are, you have to know the equation for calculating the velocity, which is this equation here. So V symbolizes the final velocity, U initial velocity, A acceleration, and then T to just represent the time. So acceleration is given by, this is just making A subject to the formula. You move this to the other side to be negative, so V minus U divided by T. That is just expressing acceleration with respect to other variables. So this is one of the most important equations which we're going to be using when dealing with acceleration time graphs. Again, we have this equation here. This equation is for calculating the distance, the distance between or the distance covered by an object. And then this another equation, this form is another form of calculating velocity. This is the final velocity when you are not given time in the question. You only have initial velocity, final velocity, acceleration, and displacement, which is the distance. So if you don't have time, you can calculate you can calculate any of these variables. You can calculate U by making it a subject of the formula. So this is just moving this to the other side and then you solve. So again, another important thing which you have to know under this topic is areas for some common shapes which you might encounter when solving these problems. So one of them is triangle. We're all familiar with the area of a triangle. Area of a triangle is given by half multiplied by base multiplied by height. So this is the base of the triangle and this is the height. And then you also have to know how to calculate the area of a rectangle. These are basic shapes. So the length here, you multiply it with the base here, you get the area. And then this is a trapezium. The trapezium, how do you get the area? The area is, there is this upper length here, which we define it as A, and then the base from here to here, and then the height from here to here. So the equation for calculating area is half A plus base multiplied by h. So there you get the what? The area of a trapezium. Okay, so we can't just be talking about acceleration time graphs without doing an example. So I have set a nice example here for you guys to see through. You try to solve it on your own. First, you have to pause the video, then you solve, and then compare with my solutions here. So this time graph here, as you can see, represent the vehicle, the motor vehicle moving from 0 here. It accelerated and then reached a speed of 8, and then it moved with a constant. So when you see a straight line, meaning it's a constant speed, the speed is not changing. And then here it's a negative slope. This is a positive slope, meaning it's accelerating. This is a negative slope, meaning it's decelerating, reducing speed. So our interest is to calculate the acceleration from 0 to 2 seconds, from 2 to 4, and then in the last 4 seconds, the distance moved by the motor vehicle for the whole journey. So how do you solve these questions? First of all, you have to check the particular part of interest of the graph. Yeah, so if they say 0 to 2, go to the graph. So you start from here to here, meaning you're only considering this section, 0 to 2. So meaning this is your initial time at the beginning, and then time at the end. So time at the end, you also get the velocity at the end. Velocity, time at the beginning, velocity at the beginning. So this is the time, the t final. And then what is this velocity? The velocity is 8. And then the initial time is 0 seconds. What is the velocity at 0? It's 0. So you just place in the values. V represent the final velocity, U initial velocity, T final time minus Ti initial time. So V final velocity, this is the velocity you get at the final time. So final time here is 0 to 2. Final time is 2. What is this velocity? 8. So that is our V. And then initial time is what? 0. What is the velocity here? 0. So that is our U. So V is 8 minus U. And then the final time, which is 2 minus initial time 0. So you get 8 divided by 2 seconds, giving you the answer of 4 meters per second squared. Part 2, from 2 to 4. 2 to 4. So you move from here 2 to 4 seconds. So meaning this is your initial time, and then this is your final time. So the velocity here at the final time is V. The velocity at the initial time is U. So final time 4. What is the velocity here? Is 8. U, velocity at initial time is 2. I mean time at initial time, this 2 seconds, the velocity is what? 8. So yeah, so you write V minus U over T final minus T initial. So our final velocity is 8, and our initial velocity is 8 as well. And then our final time is 4 minus initial time 2. So 8 minus 8 is 0, you get 0. Divided by 2, you get 0. So in other ways is, if the velocity, this symbolizes the velocity. If the velocity is not changing, meaning it's a straight line, the acceleration is what? 0. You don't have to calculate anything. You just state, if the velocity is constant, the acceleration is what? 0. But in case you don't know that, you have to show, like I was doing here, you show that you know what you are talking about. Because saying it, some other people may not understand what you mean. So you have to show that at final, T final, this is the velocity, T initial, that is the velocity. You subtract the 2, you get 0. And then the last 4 seconds, so we are here. So is this distance. So our final time is what? 8. You should always consider this. Go to the last time. The time you are given is 8. The final time is 8. And then the initial time is what? 4. So here at 8, what is the velocity? This is our final time. What is the velocity? 0. You see here, it didn't move to any point along the speed variations. Yeah. So at T final, V is 0. And then at T initial, because we're moving from 4 to 8, at this time, U is what? 8. So our U is 8, our V is 0. So you just substitute in the values. V is 0, and then minus U, which is 8, and then the final time 8 minus initial time 4, you get negative 8 over 4, which gives the answer of 2 meters per second squared. So and then the last part, to calculate the speed, or I mean the distance moved by the motor vehicle the whole journey. So this is now the problem. These things now takes us back to the part where I was explaining, to know some common shapes which you might encounter. So this shape, if you don't know it, is a trapezium. So a trapezium, you have to know how to get the area of a trapezium. So the area of a trapezium is given by A plus B plus H. over 2. So you have again to know how to identify the variables a, b, and h from the shape given. So if you come here, a, we say this is a topmost length from here to here, from here up to here. So you can get it by subtracting 4 minus 2. It will give you the value here. And then the base is from here up to here, which is 8. And then the height is from here to here, which is what? 8. So just substitute the values. A, you get 2, and then plus b, which is the breadth or the base, 8, multiplied by the height, 8, you get what? You substitute 2 plus 8, which is 10, multiplied by 8 divided by 2, you get 40. Or you can subdivide the whole shape into components. So like you can see here, we have 3 shapes. We have a triangle, 1. We have a rectangle, which is in the middle here, and then the triangle at the far end. So you can get the area of this, you add the area of this, you add also the area of this. So area of a triangle is given by this formula: half times base times height, plus at the middle there is a rectangle. Rectangle is L times B, and then another triangle, B times H. So you add these areas, they'll give you the same answer as this one. So yeah, you press in the values: half, breadth or the base of the initial triangle, the figure 1, the base is from here to here, which is 2, and then the height is what? 8. So those are the values I was writing here. And then for the rectangle, which is in the middle, the length is 4 minus 2, which is 2, multiplied by the height, which is this, which is 8. So that is our 2 multiplied by 8, plus half. The last one, the base is 8 minus 4, which is 4, multiplied by the height, which is what? 8. So you still get the same answer as the first part. Yeah, you still get the same answer. So you can either solve shape by shape, or if the shape is not so complex, if the shape is easy, you can easily tell, okay, the shape, okay, this is a trapezium. You can use the formula for the trapezium. But if you're not sure of the shape, you use you divide the shape given into different components, and then you solve the area of each. So distance is equal to the area under the graph. No wonder we are calculating areas of respective shapes. Yeah, so to conclude our lecture for today, let's consider another example here. So example 2, the figure below shows the speed time graph for an object that moves along a horizontal track. So that is the shape given. It started from rest. As you can see, this slope is a positive slope, meaning it was accelerating. And then a straight line, if it's a straight line, I've said that, meaning the speed is not changing, it's not accelerating. In short, the acceleration is 0. So for this shape, we are to calculate the acceleration of the object during the time from 0 to 4. So that is from 0 here to 4, and then from 4 to 6. So you can easily calculate this one. From 4 to 6, you can easily tell that it will be 0 here because it's a straight line. Velocity is not changing. So the acceleration is what? 0 meters per second squared. But for those who don't know that, you have to calculate and show it in your calculations that you know what you're talking about. Okay, so this is where I was just showing the V. So the final time for the first question is 4, and the velocity at that final time is 8. So you get 8. V is 8, and then T final is 4, and then initial we are told from 0. So it's 0 here. Time initial is 0. What is the velocity here? Is 0. Yeah, so you just place in the values 8 minus 0. You get the values these, and then equal to that. For part 2, 4 to 6, 4 to 6. Our final time is 6. What is the velocity here is 8. And then our initial time is 4. What is the final velocity? What is the velocity I mean at 4 is also what? 8. So our u and v, they are the same. So 8 minus 8 divided by 4 divided 4, I mean 6 minus 4, you get 0. So on the numerator we have a 0, and then in the denominator you have a 2. Any number 0 divided by any number is 0. And then now we're told again to calculate the distance moved by the object in the first 4 seconds. So first 4, mind you, you have to read the problem statement nicely and understand. First 4, from here to here is different from the first one we had. The first one we had was the whole journey. Now this one, meaning we are not including this part because they are saying the first 4 seconds. So it's just this here. So you just get the area of this first triangle. So the base of this triangle is 4, the height is 8. So you just calculate base multiplied by height. So our base is 4, our height is 8. You multiply, you get 16. And then we have a bonus question here. Given the object of mass 3 kgs, determine the force acting on an object. So here you just want to, they're asking you to calculate the weight. So weight, you know weight, the force exerted on an object due to acceleration, due to gravity. So how do you do that? You use the simple formula. Weight is calculated as weight equals to mass times acceleration due to gravity. And this is the rounded off values which you guys use in your textbooks, and it's a highly recommended value which you guys use, because the actual value should be 9.81. Yeah, but they use 10 in most of these textbooks. So when using this formula, just know that mass has to be in kilograms. Yeah, so you just multiply. The mass was already in kilograms, so if it was in grams, you have to convert it to kilograms, because the equation won't work. The SI unit for mass is what? Kilograms. Yeah, so you just multiply here. The things are already in order. So 3 multiplied by 10, you get 30 kg meter per second squared, which is just the same as Newton. So Newton is an SI unit for the force. Yeah, so thank you so much for watching. Please remember to invite your friends, comment on the topics which you want me to make videos on. Invite your friends, subscribe. Please remain blessed, and kindly know that I will upload another video very soon on electrical circuits, physics. Yeah, well, we'll be talking about how to calculate power, adding resistors in parallel, resistors in series. It will be a nice topic to look at. So you guys, you have to like my video, subscribe, and then invite your friends, share it. Thank you for watching. Have a blessed day.